Okay, so once we have the fact, the lemma basically just worked for three of these parallel lines, right? That if I have a transversal T that cuts parallel lines such that, cuts three parallel lines such that equal segment lengths are created between the parallel lines, if that's true for T, then any M transversal, any new transversal M that I draw will have the same relationship. That's what the lemma proved. And so the theorem is just an induction proof um, where we assume, and let's talk about how this goes. So we assume that for any k that's at least 3 and up to, that's the dot, dot, dot here, dot, 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 up to n parallel lines, right? L1, L2, L3 up through Ln, if it's true that any transversal that cuts n parallel lines in such a way that the segments between the parallel lines are congruent, then any transversal that cuts the parallel lines will have the same property. Okay, so we assume that that's true up to n, and now we have to prove it in the n plus 1 case, n plus first case. Well, so we're going to assume that it was true, right? We know that these guys are congruent. All of these are congruent up through n, right? So I get this last one. But now we're assuming that this one, right, that it cut another parallel line, n plus 1 now. It cut the n plus first parallel line in such a way that this segment here between y and z is also congruent. And we need to prove that this guy, that segment is congruent as well. Okay, well, how do we do that? Well, we can apply the lemma to this situation down here, right? Which is what this is saying. So that's how the induction proof goes, and this is actually the generalized principle of induction, where it's true for all k up to n. And I'm not going through all the details, and that's purposeful. This had two cases, right? What if we had chosen some m that was parallel to t, and then we have a slightly different proof that we're doing? Oh no, actually that's taken care of because of the cases before. Yeah, we're good. We're good. This is the whole proof. And so it's just a straightforward induction proof on using lemma 3, using the transversal congruence lemma. And now we're going to be able to prove the median concurrence theorem.